Welcome, everyone. Thank you for joining us here. I know there are so many other great talks happening at the same time. It's hard to pick which one to choose, but thank you for choosing us. My name is Julia, as you can see on the screen. I'm a Principal Developer Relations at -0 as of last week. Before, I was with Veeam, so doing data protection and backup. That's why I think we ended up also submitting this talk. And I'm here with Carol. She's a cloud architect. And between us, we've spent a lot of time, living the intersection between reliability and data. And where things you deploy aren't just services, but they really things that your company relies on. And at Veeam, I've also helped organizations protect workloads in and around Kubernetes. Now I've shifted a little bit, and -0 is more observability, but I think it's still very important to talk about it. So a little bit about us. We're both CNCF ambassadors. I'm also an AWS container hero. We're very involved in the Kubernetes and cloud native community. I organize some events in New York, so if you're ever there, feel free to hit me up. Would love to grab some coffee. Carol, you want to talk a little bit about yourself?
Yeah. Well, hi, everyone. My name is Carol Valencia. I think it's fine with my speaker. Yeah? Yeah. It's different when you are not with her. But yeah, I used to work as a cloud engineer and next as a customer architect in companies like Aqua Security and Elastic. And I think that is my experience in the cloud native world. Also, I am very happy to join to the TAC Resilience Operational that is also helping with new initiatives. And yeah, I'm very happy that meet you, everyone, and thank you for being here.
So let's start with how we got here. When Kubernetes first came onto the scene, it was all about stateless workloads. So web APIs, front ends, microservices that could scale up or down without worrying about data persistency. If a pod died, it would come back up somewhere else, and that was fine. But fast forward to today, that's not the case anymore. That model doesn't reflect the reality. Now we're running databases, message queues, caches, and object stores, even AI workloads on Kubernetes directly inside our clusters. So we've moved from Kubernetes as an orchestrator for microservices to Kubernetes as the new data center. And that gives us great flexibility, scalability, and control. But there are still a lot of issues, especially with the data in there. Kubernetes was never designed as a data platform. It abstracts compute beautifully, but it doesn't abstract data integrity, data retention, or access control. That's still on us. You've probably heard also the shared responsibility model. You can also take that into account as well. So the challenge is it's not that Kubernetes is insecure, it's that the way we use it evolved faster than the way we secure it. So where does the risk actually live? I think there are a lot of areas. I just put some here on the slide, but we cannot enumerate enough. And today with the attackers and new things coming up with AI especially, there are new risks that we don't even know. But a few of them is misconfigured storage class. So the wrong defaults can make your volumes insecure or non-resilient. There is volume lifecycle gaps where data gets deleted, but the persistent volume remains orphaned. There is snapshot exposure, because yes, snapshots are CRDs, and their metadata can be read. Ransomware and mutating pods. Ransomware, it's a big thing. I think we should have another talk just about that. Backup sprawl and orphan PVCs as well, which is the quiet risk. They sit there forgotten, but often there is a lot of sensitive data in there. And together, they create a pretty massive attack surface. If we map the risks to the Kubernetes storage architecture, you can see they exist at every layer. Again, storage class level where you define the backend, the persistent volume claim level where you allocate it, pod level where it's mounted and used. Then there is the snapshots and backups, which usually are handled outside the cluster. And each of these entry points, if it's not correctly configured, they can be a big problem for your organization. But the good news, there are things we can do about it. That's why we're all here in this room. I like to group this strategy into a few verbs. So 5 verbs, which is encrypt, restrict, detect, retain, and test. And if you apply those 5 verbs, 5 ideas consistently, you're already way ahead of most organizations. So we're going to go through them, and then later Carol will show us a few demos for these concepts. But first, it's about securing your storage class. The problem is that most teams, they just leave it untouched. They are fine with the default standard or GP2 class, which often has the reclaim policy delete. And that's great for CI/CD pipelines or other things, but it's lethal for production. And the fix is very simple. You just set the reclaim policy to retain, and that ensures that even if a PVC is deleted, the underlying data still stays, it stays until you explicitly remove the PV. Next, also encrypt at rest. So most CSI drivers, they support it through a parameter. And then it's one of those things that's never by default, but once you set it, you get built-in encryption with 0 performance penalty. Then you also add mount restriction to block privilege escalation path inside the compromised pod. And finally, set volume binding mode to wait for first consumer. This ensures that the scheduler doesn't bind a volume until the pod is scheduled, which avoids classical topology mistakes like creating a PV in a zone A for a pod that runs in zone B. So yes, in one YAML block, you've hardened the base layer for every workload that uses storage in your cluster. But after you secure the storage class, the next challenge is consistency. So how do you make sure that developers actually use it and don't accidentally create PVCs with insecure settings? So that's where admission control comes in with tools like Kyverno and OPA Gatekeeper. They run right inside your API server request path. And before Kubernetes even writes an object to etcd. With Kyverno, you'll see later on with Carol, you can express policies in YAML like you see here as well. And here we're validating that any PVC must use storage class name starting with secure. So if someone tries to create one with standard or default, for example, the admission webhook blocks it immediately. And it gives a clear message back to the user. So it does 2 big things for us. The first one, it stops drifts. That's great. No more one-off PVCs using unencrypted disks. And second, it codifies intent. So you can version control these policies, and then you can test them in CI. You can also roll them out like any other piece of code. Now, in larger organizations, we've seen teams layering policies engines. So they use, for instance, Kyverno for Kubernetes native validation and OPA Gatekeeper for cross-cluster governance or more complex logic. Now, we've locked down the defaults, great, and enforced policy, amazing. But there's still a huge blind spot, which are Kubernetes snapshots. Most teams, they treat snapshots as metadata. And in reality, they are full readable copies of your data. When you create a snapshot in Kubernetes, it stores it as a CRD, and they are API objects. So, which means anyone with RBAC permissions, they can get or list these resources, and they can see the snapshot's backend ID. And with that ID, you can do so much. You can, for instance, rehydrate the data outside the cluster. As you can see here on the screen, for example, if you're using AWS, you can literally run this AWS EC2 create volume, and then with the ID, and then you have a clone of production data in a new region or a new account. And that's how a lot of the insider breaches happen, not by breaking into storage or coming from outside. It's mostly reading snapshots metadata through Kubernetes. So it's a big thing. And the fix is very straightforward. Just you have to limit the RBAC verbs for volume snapshots and volume snapshots content to just a small admin group, people you really trust. And scope those resources to namespaces. Don't let cluster-wide services accounts to have blanket access. Now, the other piece in the chain is backups. I am going to talk a little bit about it, but again, it's a whole nother topic. We usually don't really pay attention. It's the last thing we think about, but it's usually the thing that saves your organization when something bad happens. When I talked to teams running backups in Kubernetes, one of the first red flags that I saw was just having static credentials there. And things like AWS access keys or Azure storage keys, they're sitting in secret or config maps, and they're mounted on a pod. And the problem is that these credentials, they never expire, and they often have broad permissions. So if the pod is ever compromised, those keys are now on the attacker's hand. Great, right? We can't even imagine that happening. And the right approach is using workload identity. So for instance, here, we're annotating our service account like this. We're binding Kasten's backup pod to a restricted IAM role that only allows S3 put object and S3 get object on a specific backup bucket. And with that backup job, it becomes a trusted workload with ephemeral credentials and not just a privileged pod with permanent access. And also, if you combine these with immutable buckets, so if you use object lock on those buckets, no one will have access to it. No one will be able to modify, delete, encrypt it. It's in a warm state, and then you don't have to worry about that for the period that the retention set period that you decide. Awesome. So far we've hardened the environment. That's great. But the truth is, and you probably know that, that's why you're here, there is no configuration that is bulletproof. There is always something new, and a breach can happen with something that we might not even imagine. And if something slips through, a compromised image, for example, or an exposed service account, what will tell us that our data is being tampered with? And that's where another open source project that I really like comes in. So Falco is where runtime detection, that's what it does, runtime detection. So it runs a daemon set on every node, and it hooks into the Linux kernel, for instance, or eBPF, and it listens for syscalls from our containers. So this simple rule here looks for any file deletion events into the Postgres data directory, and if someone or something runs remove or has a misbehaving process and ends up wiping part of our volume, Falco will catch that up and will catch the syscall and fire an alert instantly. And you can fire to our Slack, to, I don't know, Prometheus, our SIEM system, wherever you want. So it's very helpful. And now the final layer, we talked about it a little bit, which is the break glass protection. It's immutable backups. A lot of teams, they still assume that snapshots are backups, and it's not the same. Remember, snapshots, they are metadata. They live in the same environment where, same credentials and same blast radius where your application lives. So if a ransomware or an insider from your company that has malicious intentions, they compromise your cluster or your cloud account, those snapshots can be deleted or encrypted, overwritten. But if you have immutable backups, that's not the case. They are protected for that period that you've decided. And here the big takeaway is that immutable backups, they break that ransomware kill chain, because when everything else fails, you still have the backups to, trust and get that data backup and running. And with that, now I'm gonna pass it to Carol. She's gonna show us a few demos about what we talked about already.
Yeah. Well, when Julie invited me to this talk, I tried to create my environment to data, and believe me, it wasn't easy. I am not a DBA, and I started to install it, as you can see, several stateful sets, and by default, I started to create a many storage class that you only need to configure, like Julia says, one default class, but you can be very easily misconfigured and lost it. And that is why Kyverno and OPA will help us to automatize this control. Like you can see that you are searching this bad practice, that how many default storage classes do we have in our Kubernetes environments. So with this, you can automatize these controls. And about compliance and security workloads is also because, as I say in the before talk, deploying a database is not easily, it doesn't work on the first step. And when you try, maybe you will try with operator. And that will be also the same stage when we are talking about machine learning pipelines and also vector database that you would like to try to install. You will do it using operators of the providers. That means that you will install many custom resource definitions that you don't know what are doing. Many with security problems, airbag, and what's the reason? That's the importance that you need some tools that take a look of the workloads, because you can take a look in your YAML as a best practice, like 3V, and you can do a scanning of your YAML, but also you need to do the same for the workloads that will be installed by default for the operators that you don't know. You don't have these YAMLs to review it before. And so it will be more important to have these products inside our cluster to review the best practice. Yeah, like security context and read-only, they will notify you if you don't have it enabled by default. That is controls that Kubernetes already provide for us. Here is like Falco. You can see it how it works. And this is a sample that how can you alter your data. You can deploy with a stateful set, even a deployment that you have a volume mount. But you need, by default, Falco and the tools is validating the default special folders like etc and others, but you have your data in special names. You need to specify by custom rules, no? Because if you are saving your data in data my company, you need to customize the rule to identify these host paths. No? But in general, any endpoint detections will help you with that. That is the main point about data storage and data. Where is the data saved when you deploy these containers? And here is another sample as how can be happen a ransomware. At the end is altering your data, stealing and making a zip and tell you, give me more money for these data. And it's very easily to someone with, I don't know, lateral movements try to go access on your pod and get these informations. And we have some resources inside of Kubernetes like volume snapshots that you can set in that maybe with a cron job to try if it's happened someone to try to recover your data and list if it's altered or not, you can use it. We have some projects that also yesterday in some talks on the maintainers that was saying about how volume replications that is really not defined inside of the CSI. So this is really a topic that is open for everyone want to do more research, because it's a topic about disaster recovery, that how can you replicate volumes in real time and using Kubernetes.
Yeah, no, yeah, we've been mentioning a few open source projects. We didn't have time to create like demos for all of them, but there is also another open source project from the CNCF, which is Canister, and it really basically provides a framework, an automated framework for application consistent backups in Kubernetes. So it defines standard blueprints for your backups. It captures the stateful application data, and then you have just a clean and consistent recovery point if you need to do those backups and for disaster recovery, like Carol was doing. So then you push those to those immutable object storage buckets, for instance, and then you have it. You're better prepared. You're more secure. Yeah.
Yeah, and as I say, I try to deploy a vector database, and mainly I use Milbus because they have many Kubernetes manifests, very friendly to do it. And it was like a lot of workloads installed by the operators, and you need to take care of more storage class, resources that will be created by the node specialized and by CPU and memory. And yeah, and this will be the things that I think you need to take care in the future when we talk about how to deploy machine learning or AI in Kubernetes. And you have some open source vector database that already is enable these features of saving a vector database in Kubernetes. And as the end, like this is like a security overview, because at the end it will be to do the best practice on security about container, that you already have these misconfigurations that you can use, and vulnerabilities that you can use 3V or other open source tool that is already mentioned there. The supply chain attack that is also that you can use signing the containers using frameworks like Salsa, Sbone, that all the security friends, they know about it, but you need to apply for that even when it's security data, and apply the Kubernetes security that you have authentications, authorizations. I think that will be a nightmare for the airbags because you have more resources that you need to manage and have the minimal privilege to apply it. And use the pod security standards for not be a root in container. So, but you needed to apply it's always the same mistakes, but because when you do it, it's very hard to deploy the workloads. Network isolation, secrets, and yeah, and I want to mention these two groups that I was discovered in these days in KubeCon. That is for NVIDIA, that they have the Kubernetes device resource assigned, that there are specifies and creating how to do this manage about machine learning and more labels to know the resource. So this is a work group that you want to join it. It's also ready the endpoint. And also another initiative that is Cloud Native Business Continuity, that also is talking about how to do this active, destructive, disaster recovery about database. And also if you are also already doing in your companies about these topics, it will be very nice if you can join and share your experience there and try to create a blueprint about this. Yeah. Okay.
And we're also giving other talks throughout the conference. If you want to come see us, I'm giving a talk with a friend that is here on observability, how to bring observability into the data center. Also, another talk about platform engineering. And Carol is also giving 2 other talks, right?
Yeah, I have this opportunity to talk more about security, the butterfly effect, and also for talk more about the TAC of resilience, explaining the new initiatives in the TAC operational resilience, that also if you have interest, you can join to meet everyone. It's a panel mainly.
And with that, we wanted to thank you. If you want to connect with us, those are our LinkedIns. And we'll be here throughout the conference. It was a pleasure. Thank you again.
Thanks, everyone that is
here.
here.
We have time to take one question.
Yes. I think we have a question. Yeah.
Hi. So you mentioned, monitoring for, file activities like, removing a database file, removing files. But, is there any solution for, if you manage to remove the file, it's already too late. The data is, compromised, your service may be interrupted. So how do you move from, just monitoring to, actively blocking access to an application, especially from inside attackers? Outside attackers is easy to protect with service accounts and whatnot, but from an inside attacker that has enough privilege to, to access your Kubernetes resources, how do you do blocking at that stage?
Yeah, I think like runtime protections, that will be the endpoint protection that is very in security, that you need to monitor about the host paths, that is your data. And when when someone wants to access, read, mount, these kinds of Linux, these first steps, and with some eBPF tool, you can recognize, no?
But if you don't, I'm sorry. But if you, don't know how, is there, what was the open source product that you mentioned that does the monitoring? If you don't know what, who's going to be attacking your data at what point, how do you prevent a privileged user from actually deleting a file, deleting a database, causing service interruption? Is there any solution out there that does that, or, in the open source world, or no?
No, it's really tricky because it's not a simple solution. You have to have a lot of detail. That, for example, where is my data? You will know when you do the mount of the YAML because you specify where is your data. So in some moment, I think you will know where is the data specifically, but it's tricky to know to monitorize all the data that you deploy in the millions of pods. But yeah, maybe started to, it's not so simple to...
But as you were asking if there is one solution that does that, I don't think there is just for that, especially if it's an insider person, which is way harder. So not that I know of. Yeah. Mm-hmm. Cool. Thank you so much, everyone. Have a great KubeCon.